Hello, everyone. Welcome back. Today, we're going to talk about what is and isn't a function. So, how do we know if something is a function or just a relation? Well, a function must have exactly one output for every input. Or, in other words, for every x value, there must be only one y value that goes with it. If there exists any x value in our relation, that has two or more y values, then it's not a function, it's just a relation. So let's talk about whether the table of values or diagram or graph is a function. First, we're going to start with table of values, but we will also move on to some graphs and things as well, and we'll talk about how to tell with those two. Okay, so let's start with A. A looks like for the inputs, we have -2, -1, 0, 1, 2. And for outputs, we have 1, 2, 3, 4, and 5. And so as you notice, every input has a unique output. There is no such input that has multiple different outputs. And so therefore, this is a function. Okay, what about for B? B is the same way, right? For every input, for every x value, whether it's -2, -1, 0, 1, or 2, all of them have just one output, so this is also a function. Now, I do recognize that for this one, there is an output that gets repeated. Notice that both -1 and 2 have 2 as an output, but that's okay, right? We're allowed to have the same output multiple times. We're just not allowed to have multiple outputs for the same input. And so this is okay, it's still a function. Okay, what about C on the other hand? Well, this one is not a function, and here's why. This one is not a function because right here we have that the output for 1 is 2, but also the output for 1 is 6. And so the same input of 1 has multiple outputs, 2 and also 6, and this is not possible for a function, and therefore this is not a function. Then for our last one here, this one is also not a function. Reason being is because notice that for this one, we have -1 and has -6 as an output, and also that -1 has -5 as an output. So again, we have two outputs for the same input, and we can't have that for a function, so this is not a function. Okay, now let's look at these diagrams and determine whether they're functions. Okay, so looks like for this first one here, the input -4 is associated with output 1. That's okay. Input of -3 is associated with 2 as the output. And -2 and -1 do have the same output. However, notice that every input has only one output, right? None of them have a second output. And so E is a function. Okay, what about F? What about F? Well, looks like 2, 3, and 4 only, as inputs only have one output each, but number 1, it has two outputs. Number 1 has an output of -30 and an output of -10, and that's what makes this not a function. All right, what about G? H, I, and J. So these are graphs. So how can we tell with a graph? What we do is called the vertical line test. If there exists any place on the graph where I could draw a vertical line and it crosses twice or more than twice, then it's not a function. But if there is no such place where I could do that, then it is a function. And so, for example, all lines other than the vertical line itself are functions, right? However, when it comes to other types of relations, that's not always the case. So this one here, notice that no matter where I draw my vertical line, every single vertical line I draw is only going to cross this graph at one place, right? Only one here, one here, etc. Right? There's no such place where I could draw a vertical line and end up getting There's no such place I could draw a vertical line and end up getting two places. So this is a function. What about this quadratic function? Well, this quadratic function also is a function because same kind of thing. There's no such place where I could draw a vertical line and hit two spots. Now, I, on the other hand, is also a type of quadratic. This is a inverse of a quadratic. However, the inverse of a quadratic is not a function because there's many places, in fact, like this vertical line here, just as one example, where I could draw this vertical line and it hits my relation in two places. I could also do that here or any number of places, but I really only have to show that that's the case once to show that this is not a function. Same with this circle. A circle is never a function because with a circle there's same kind of thing. Anywhere other than the very edges of the circle I could draw a line, or outside the edges anywhere in the domain, I could draw my vertical line and end up hitting the relation in two places. So therefore, this circle is not a function.